Hello students, welcome to Saurav Sir's classes. The problem that we have in hand today is let f from close 0 to 4 to r be a twice differentiable function. Further, let f of 0 equal to 1, f of 2 equal to 2 and f of 4 equal to 3. Then there does not exist x1 belongs to 0 comma 2 such that f prime of x1 equal to half. There exists x2 belongs to 0 comma 2 and x3 belongs to 2 comma 4 such that f prime of x2 equal to f prime of x3, f double prime greater than 0 and f double prime less than 0. Now by mean value theorem, I am applying mean value theorem to the points 0 comma 2. To applying this to the point 0 comma 2, we have f of 2 minus f of 0 equal to 2f prime of x1 for some x1 belongs to 0 comma 2. Now applying it to 2 comma 4, we have f of 4 minus f of 2 is equal to 4 minus 2, that is 2 f prime of x2 for some x2 belongs to 2 comma 4. Now what is f of 2 minus f of 0? It is 1, so f prime of x1 equal to half, and f of 4 equal to 3 and f of 2 equal to 2, so this is f prime of x2 equal to half. Now since f prime of x1 equal to f prime of x2 and x1 belongs to 0 comma 2 and x2 belongs to 2 comma 4, we see that B is the correct answer. Let us move on now to the next question. Let f(x, y) equal to x square minus 400xy square for all xy belongs to r square. Then f attains its local minima and local maxima. I beg your pardon, the question asks where does f attain its local minima. We have 4 options and let us see how to solve this. Whenever we have a question which asks for local minima or local maxima, it's always advisable to compute its Hessian matrix, the matrix formed by its double derivatives. Firstly, dou f dou x is equal to 2x minus 400y square, and dou f dou y is equal to minus 400x times 2y, which is equal to minus 800y. Now at 1 comma 1, dou f dou x is equal to 2 minus 400 and dou f dou y is equal to minus 800. Therefore dou f dou x, dou f dou y, these are not equal to 0 at 1 comma 1, and hence we do not have a local minima. To have a local minima, the first condition is that the first derivatives dou f dou x dou f dou y have to be equal to 0. However, at 0 comma 0 we see that at 0 comma 0 dou f dou x equal to dou f dou y equal to 0, and so we need to compute the double derivatives now. What is dou square f dou x square? It is 2 dou square f dou y dou x which is equal to minus 800y dou square f dou x dou y is equal to 0, and dou square f dou y square is equal to minus 800. Now we have to compute the Hessian matrix. As I already said, Hessian at 0, 0 is dou square f dou x square, which is 2, dou square f dou y dou x, which is 0 because minus 800y is 0, dou square f dou x dou y is equal to 0, and this is equal to minus 800. Now the two eigenvalues are 2 and minus 800, hence it's not positive definite, neither negative definite, and it's not a minima. To be a local minima, it had to be a positive definite matrix. Both the eigenvalues had to be positive. So local minima neither at 0, 0 nor at 1, 1. Now we will move on to the next question. The next question says, let g from 0 to 2 to r be defined as gx is equal to integral of 0 to x minus t times e to the power t dt. The area between the curve y equal to g double prime x and the x-axis over the interval 0, 2 closed is what? So what we have to find out is g double prime x and its integral over the area 0, 2. Now gx is equal to integral of 0 to x minus t e to the t dt. Let h of t equal to e to the power t and let f of t equal to t times e to the power t. Therefore gx is equal to x times integral of 0 to x e to the power t dt minus integral of 0 to x t e to the power t dt. gt is equal to which just says that gx is equal to x times e to the x minus 1 minus 0 to x t e to the power t. So now t e power t minus e power t, when we differentiate this we get t e power t minus e power t plus e power t, t e power t plus e power t from this and minus e power t from this. These gets cancelled and we get t e to the power t. So here we have x e to the x plus e to the x minus this gives us a 0 and this gives us a 1. So here we have a minus 1. So what we are left with is e power x minus 1. So g double prime of x now is equal to e power x and integral of 0 to 2 g double prime x is equal to integral of 0 to 2 e to the power x, which is e square minus 1. So A is the correct answer. Thank you.